Hello viewers, in this lecture we'll be talking about the tangent of a circle in the rotational motion. What does it mean by that? Whenever we are moving in a circular motion, an object always tends towards the tangent. It always makes a slope. Just suppose that an object that moves from this point to this point is actually moving in a circular direction, but in a condition if it got free from the source of the tiness, so it moves in a straight direction, a rectilinear direction, making a tangent. So basically, what is the concept behind it? Theta is always vector for the small values only, not for the big values, but for the small values, the theta becomes vector. Now, in the axis of rotation, it is basically perpendicular to the plane of the circular motion. Axis of rotation always has 90 degree with plane of rotation. If you will rotate it according to this in the 3D direction, so basically the axis of rotation, it's in the center, coincides between and makes a 90-degree angle with the circular motion. Now, whenever there is such condition in the rotational motion, all the momentum, first the velocity, the circular velocity plus the momentum, the angular momentum, in addition with the displacement. This is basically velocity and this was displacement. These all move in a single direction. The momentum, that is basically mvr, the mass, velocity and the radius moves in the same direction. The tangent of a circle changes its direction throughout the motion. Like if a person leaves this ball at this direction, so basically it will move in upwards direction. But if a person leaves it here, so it will move in on the left hand side. So this is how tangent works. Now there is a specific rule by which the direction of the tangent can be measured. So that rule is called right hand thumb rule. This rule basically says that curve the fingers along the motion of the object. Just for instance, let me remove it first. Okay. Now just for instance, this is a rotational motion. If in a condition the object moving in this direction, so what you have to do, you have to curve your fingers like this and your thumb will point the direction of the motion. In the 3D figure, it will be something like this is the axis of rotation, this is the object moving. If the object is moving in this direction, you have to curve your fingers. Let me change the color. You have to curve your fingers in this direction. And your thumb will point the direction of the motion. This is how we measure the direction. Keep that in mind. Whenever we are talking about the right hand thumb rule, we use 3 fingers. First of all, our thumb, the index finger and the middle finger. Every time when we are using the thumb, so this thumb basically shows the third vector. The index finger shows us the second vector and the middle finger shows us the first vector. So just suppose that I want to find the direction of the displacement. So displacement is equal to theta into r. This is the relationship. So here the s will be first, this will be second and this will be third. That probably means the radius of the circle will basically lie on this direction. Now here there is some mistake that I have said that S will be this first one, so S will be the third one, this will be the first one, and this would be the second one. That probably means we have to find this direction of S. So the direction of S would be the direction that thumb will indicate. So it's really important to keep the things in order. We cannot write S is equal to R theta. That will basically create a mess, because when we point and direction by right and thumb rule, so it's something like this. So basically here thumb shows us the third direction. This shows us the second and this shows us the first. So here in this condition theta would be in this direction and the R would be in this direction, but in the actual condition theta is in this direction and the R is in this direction. So we have to keep that in order. And that's all about today's lecture. I hope that you get it.